Dear students, now I am going to teach in the differentiation. Then we are going to be learn the one more concept, that is a logarithmic differentiation. So already we have been learned the properties of the logarithmic differentiation. Sorry, only for the logarithmic is log of m n equal to log of m plus log of n. Log of m divided by n is equal to what? Log of m minus log of n. And the log of m to the base a is nothing but log of m divided by log of a, and log of a to the base a is nothing but 1, and log of 1 or the log of e is always equal to what? 0. So those are the what some basic or the algebraic logarithmic we can say. Now we are going to be studying the logarithmic differentiation. So how we have to decide that how the example is nothing but we have to apply the logarithmic differentiation. There is a one simple way that we have to be come under the conclusion that we can apply for the logarithmic differentiation is whenever the term x is in exponent form. Whenever the term x is in exponent form, then apply logarithm. Whenever the x term is in the exponent form, then apply the logarithm. So, x is in the exponent form means it is whenever in the ratio or in the form of the degree we can say. So for example, whenever it is having sin x whole raised to x, a raised to x, and phi raised to x, e raised to x, and one more we can say that the tan inverse of x whole raised to 2x. So like that. Whenever x term is in the exponent form, so that we can have the example like this also, that is sin x whole raised to tan x, like that also. So here also the x term we have. Whenever x is in the exponent form, so that time we have to apply the what? The logarithm to the given function. Then we have to apply, then after that, after applying the logarithm, we have to differentiate. Getting? So this type of the concept is for the what? The 3 marks. So many times they have been asked in the examination on the concept of the what? The logarithmic differentiation. Don't forget this one. This is the one of the most important concept that we are going to be learn. Getting? Whenever the x in numbers is under bare. If the numbers are present in the ratio, in the exponent, then we can apply the x raised to n. But here what we have, if it is sin raised to x square we can apply the simple differentiation. So that time we can apply the x raised to n form, or we can apply the chain rule also. Getting? But whenever the ratio or the exponent form or the form of the degree is having the x term, so that time we have to apply the logarithmic. So these are some simple examples. Whenever the terms are in this form, so that time we have to apply the logarithm. Okay. So now I am going to solve some basic examples on the what? The logarithmic differentiation. Okay. So you have to note down the notes by pausing the video, and you have to along with you have to give the word attendance. Differentiate the following with respect to x. Differentiate following with respect to x. So first one example I will take. So they give the examples like this, that is x raised to x. Whenever they give the term x raised to x, and to differentiate this one with respect to x, so that time first we should have to take in our mind that we should have to consider this one as y equal to x raised to x, compulsory. Look here, whenever x is in the exponent form, we have to apply the log. But before that, what we have to take? This function. Whenever they give the simple function, so x raised to x, sin x raised to x, so like that, whenever they give, we should have to consider that function is equal to what? Then applying log to the both sides, so that time what it is becoming? Log y equal to log of x raised to x. Now what it is becoming? Log y is equal to what? X raised to x. Now we have to apply again here log of x raised to x means log of m raised to n. What is log of m raised to n? That is n log of n. Log y is equal to this x is taking the place here, that is x log of x. So this x is going to be take the place of here. Log of m raised to n is nothing but n log of n. Got it? Okay. So now after applying the log, we have to differentiate this function with respect to x. After applying the log, if there is any logarithmic properties, first you apply the logarithmic properties and then differentiate this function with respect to x. Okay. So log y differentiation is 1 divided by 1. Consider this one as the x. 1 by x. Then x differentiation is 1. Like that. If log y is 1 divided by y, then y differentiation is dy by dx. Now x into log of x is having. Here we have the two terms, that is u. This one is v. First you keep the x as it is. Log x differentiation is 1 by x plus. Then keep the log x as it is. Then differentiation of x is 1. So here this x get cancelled. Now 1 by y dy by dx is equal to what? 1 plus log of x. This one. Next you take this y to the RHS, to the numerator at the RHS, then dy by dx is what? That is y into bracket 1 plus log of x. I have taken this y to the RHS, then it goes to the numerator. Then what is y? Y is nothing but x raised to x. That you have to be substitute compulsory. Each and every example you get the y to the RHS. You should have to take to the RHS. Then x raised to x, 1 plus of log of x. So this is nothing but what? The differentiation of or the logarithmic functions. So this is a very simple. Whenever they give the x terms, x raised to x, whenever x is in the exponent, take that one as the y, then apply the logarithmic, then apply the logarithmic properties. After that, differentiate that function with respect to x. Whenever the y is in the denominator, take it to the RHS. So that is nothing but the logarithmic differentiation. One more example I will take. The second one, very simple. That is x raised to sine inverse of x. X raised to sine inverse of x. So here also x is in the what? Exponent form. X raised to, so here the sine inverse is having the domain is again the x. So that's why we have to consider this one as the what? Y is equal to x raised to sine inverse of x. Consider that one with the y is equal to. Getting? Okay. Then apply the log to the both sides. Log y is equal to what? Log of x raised to sine inverse of x. Log y equal to log of x raised to sine inverse of x. Next again it is having the property log of m raised to m. So that is nothing but log y is equal to m log of n. I have taken this sine inverse x to the before the log of x. So now it is sine inverse of x is u, log x as the v. Applying again the u into v. After applying the u into v, first LHS. What is log y differentiation? 1 by y. Y differentiation dy by dx. Is it? Then keep the u as it is, that is sine inverse of x. Then differentiate log of x is 1 by x. Next plus keep the log of x as it is. The differentiation of sine inverse of x is, this is standard having the formula 1 divided by 1 minus of x square. Getting? Next, very simple, take this y to the RHS, then dy by dx is equal to 1. That is y sine inverse of x divided by x plus log of x divided by root of 1 minus x square. Then what is y? from this one. What is y? Y is nothing but what? Again x raised to sine inverse of x. That you have to write down it compulsory. That is x raised to sine inverse of x. Then remaining term you have to be right. That is sine inverse of x divided by x plus log of x divided by root of 1 minus of x square. So these are the simple differentiation with respect to x for the logarithmic functions. Got it? Okay. So now we are going to be continue again some basic examples on the logarithmic differentiation is. One more I will take. Okay. At the end of the class, I will give some basic examples. Okay. As the homework, the one more is having. This is the third one example. Log of x whole raised to cos x. Log of x whole raised to cos x. So here again the power of log x. So power is having it is again in the form of x. So term is having the x. It means x is having in the exponent form, or the degree is having in the x term. So that time again we have to consider this energy what y equal to compulsory. You should have to write y. They are not going to be provide the y. You should have to consider it as the what? Y. Okay. So y is equal to log of x whole raised to cos x. Apply the logarithmic property. Log y is equal to apply log to the both sides. Log of log x log x whole raised to cos x. Log x whole raised to cos x. So now it is again in the form of log of log x whole raised to cos x. What we are going to apply again? Again applying the what? Again applying the what here? What you are going to be applying? That is log of, I will apply the log of m raised to n first, or else you can do here we have it in the form of log of m raised to n. It means log y is equal to what? Cos x. Then it is having log of log x. Log of m raised to n, that is m log of m. Okay. Then log by differentiation, 1 by differentiation, dy by dx is equal to, now it is in the form of u, this is big. First you keep the u as it is cos x. Then differentiation of log x is log of x is 1 divided by x. The next differentiation is 1. Here you have to apply the chain rule. Log x is 1 divided by log of x. Then log x differentiation is 1 by x. The next differentiation is 1. Okay. Plus keep the v as it is log of log x. Then differentiation of cos x is minus of sin x. Next, take that y to the RHS. Then dy by dx is 1. Y. Then cos x divided by x log of x plus, so plus into minus we can take here, the minus log of log x into sin x. Got it? Okay. Then next, y is nothing but what? Your log of x whole raised to cos x. Therefore, dy by dx is what? Y is nothing but, that is a log of x whole raised to cos x, and the remaining term, that is a cos x divided by x log of x minus log of log x into sin of x. So this is what the differentiation for the what? Log of x whole raised to cos x. By pausing the video, you should have to note down the notes. The next one examples. The next one examples. When it is having the two functions in the form of u plus v or u minus v. First I will take the first one. That is the fourth one example. That is x raised to x minus sin x whole raised to x. I think we have given sin x, or else you can take the sin x whole raised to x. Here, this one is also we have to consider, but here the two functions in between we have the minus. If it is having the plus, then also we have to apply the u plus v. When it is having the minus, then we have to apply the what? U minus of v. First we have to consider this one as the what? Y is equal to x raised to x minus sin x whole raised to x. When I consider this one as the what? Y is equal to u minus of v. Y is equal to what? U minus of v. Then here we have the two functions. In between the two functions we have the what? The minus. If they give the plus, then it is taken it at the u plus v. Okay. Next, differentiation of y is dy by dx. Differentiation of u with respect to x is du by dx. Then minus this one is what? dv by dx. Getting? Okay. Now, therefore, what is u? Here, what is u? What is u? U is nothing but what? What is u? U is here nothing, it is what? X raised to x. ಎರಡು ಫಂಕ್ಷನ್ ಅನ್ನು ಸೆಪರೇಟ್ ಆಗಿ ತಗೋಬೇಕು. ಇದು u ತಗೋಬೇಕು, ಇದನ್ನ v ತಗೋಬೇಕು. ಆಮೇಲೆ ಇದು this one I will, so what I will do? Okay, I will consider this one as the what? Equation 1. I will consider this one as the equation 1. After doing the differentiation, we have to substitute in the equation 1. Okay. Now, this is the u. U is nothing but x raised to x. Differentiate du by dx ಮಾಡಬೇಕು. Here, but du by dx ಮಾಡಬೇಕಾದ್ರೆ ನನಗೆ ಏನು ಬೇಕು? Here x is in the form of again exponent form. Apply the log to the both sides. Then it is log u is equal to what? Log of x raised to x. Getting? Okay. Then log of u differentiation 1 by u. Then u differentiation du by dx, because we are going to differentiate this u with respect to x. Then I'm sorry, first applying the logarithmic property. First I will keep the log u as it is. Then log of m raised to n is n log of m. Then apply the what? The differentiation. What is log u differentiation? 1 by u differentiation du by dx is equal to, this is u, this is v, x log of x, u into v. Then keep the x as it is, log x differentiation 1 by x plus. Then keep the log x as it is, the differentiation of x is 1. Okay, this x will get cancelled. Then du by dx, take that u to the again RHS, then u into bracket 1 plus log of x. Then du by dx is, u is nothing but x raised to x 1 plus log of x. Getting? So this is about the what? U. Next we have to take it for the v. V is nothing but what we have, that is sin x. We can take whole raised to x, sin x whole raised to x. Okay. Then apply the log to the both sides. Log v is equal to log of sin x whole raised to x. Again it is in the form of log of m raised to n. Then log v is equal to x log of sin x. Take x to the what? To the previous to the log. So x and the log in the pile I madri tagolbe. Because it is log of m raised to n is nothing but n log of m. Okay. Applying the differentiation with respect to x, then it is what? 1 by v is equal to u into v. This is u. This is whole term is v. Log of sin x is 1 divided by sin x. Sin x differentiation is cos x. Then plus. Write the log of sin x as it is. The differentiation of x is 1. Therefore, log of 1 by v, then it is dv by dx. V the differentiation. Okay. Then dv by dx is equal to, take this v to the RHS. Then we have to cos by sin is tan. Cot, that is x cot of x. Cos by sin plus log of sin x. Therefore, dv by dx is nothing but what? V means sin x whole raised to x. Then what? The bracket, in the bracket what we have the term? X cot of x plus log of sin x. Okay. Therefore, from equation 1 From equation 1 what we have? dy by dx. ಯಾಕಂದ್ರೆ ನಾವು ಎರಡು ಈಗ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಮಾಡಿದ್ವಿ ನಾವು ಆಲ್ರೆಡಿ. ಓಕೆ, then dy by dx is equal to what? du by dx. What we have the du by dx is x raised to x, x raised to x, 1 plus log of x plus dv by dx is, sorry, and we have the minus, minus dv by dx is, that is sin x whole raised to x part of x plus x part of x plus log of sin. So this is one, the differentiation. If y in the differentiation ಮಾಡಿದೆವು, then u the differentiation, v the differentiation, it will. So this type of the example is going to be asked for the what? The 3 marks. Okay, and here I will give some basic example from it. ಎರಡು ಮೂರು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ, ಸಾಲ್ವ್ ಮಾಡಿ, and we are going to continue some basic examples in the again the next class. That is the take the first one example is like that is sin x whole raised to tan x. Some basic examples are written. Next, x raised to tan inverse of x. Third one, log x whole raised to log x. Fourth one, this type of example I will give some basic example. Then that is having x raised to x plus log x whole raised to sin x. One more example to be practice this one. This type of example I will continue in the next class again. That is tan x whole raised to x plus x raised to I will take the x again, x raised to x. So this examples you have to be solved, and the remaining portion I will be continuing in the next class. Okay, so thank you. Or else you can take here it as well 1 by x whole raised to x. The remaining examples I will continue in the next class. So thank you.